say that you are in the woods and you find 3 sticks. Do you think you can put all 3 sticks together at their vertices and create a triangle no matter what the length? It would end up going off the other way, because if you took these 3 and you tried to make a triangle with them, you couldn't connect their endpoints, could you? Okay, you couldn't connect their endpoints. Okay, so we know that wouldn't work. Here's another. All right, here's another one, okay? And if I try to connect theirs, it's just not going to happen, is it? Okay? If I took this and tried to connect, it would, wouldn't it? Okay? So if I tried to make a connection about these, this one didn't work, and this one didn't work, right? But this one did. What conclusion do you think you could make? They what? Okay, a little bit more specific. What do we notice about these 2 compared to the third one?
Oh, 2 sides have to add up to.
Well, if they add up to equal the one big side, it didn't work, right? Okay, if you take any 2 sides, it has to be greater than the third side, right? Because when the 2 sides are less than the third side, it didn't work, right? When they were equal to the other one, it didn't work. But when the 2 sides added together so that it was greater than the third side, it did work, right? Okay, so that is the triangle inequality theorem. And it states that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. Alright, so if I add AB plus BC, that has to be greater than AC. And if I add AB plus AC, that has to be greater than BC. And if I add BC plus AC, that has to be greater than AB. So I should be able to add any 2 sides, and it should be greater than the third side. What do you think is the most important to check, probably? The 2 shortest sides, right? Yeah, it may or may not be legs, depending on what kind of triangle it is. The 2 shorter ones, right? Because that's where your problem would occur, right? Is if the 2 shorter ones weren't long enough to add them to be bigger than the third. All right, so determine whether the given measures can be lengths of the sides of the triangle. Okay, well, if I add 2 plus 4, is that going to be greater than 5? Yes. Is 4 plus 5 going to be greater than 2? Obvious. Yes. Is 2 plus 5 going to be greater than 4? Yes. So, can this be a triangle? Yes. If I look at the next one, is 6 plus 8 greater than 14? No. So, we're done. We're going to have to check the other ones, right? Okay. In triangle XYZ, XY is 8, XZ is 17. Which measures can be YC? Well, if I plug 30 in there, would that work? 8 plus 17 is not greater than 30, right? If I put 25 in there, 8 plus 17 is equal to 25, so would that work? No. 10. That one would work, okay? What about 5? No, 8 plus 5 is not greater than 15. So my answer here is C. 8 plus 5 is not greater than 17. 8 plus 10 is greater than 17, but 8 plus 5 is not greater than 17. Okay? Alright. Now, you'll be asked to find a range of values. Okay? There's more than one possible combination that you could have with numbers, right? So when you're asked to find a range, you are going to find a lower limit, and you are going to find an upper limit. And then the value of the third side is going to fall somewhere in between. So to get the lower limit, I'm going to subtract the 2. And in this case, it gives me 5. And to get the upper limit, I'm going to add the 2, which in this case gives me 13. And then the value of the third side falls somewhere in between. How would you read that inequality? Okay, a lot of people think that's how you read that. But if you heard me say 5 is less than x is less than 13, does that even make sense? We're talking about the value of x, yes? Perfect. X is greater than 5 and less than 13. Now if I say that to you, does that make sense? Because then you know what the values of x are. It's got to be greater than 5 and less than 13. So that's how you would read that. You always start with the variable and then how the numbers are related to it. Okay? Alright. That would not be mathematically correct. I mean, technically, yeah. It'd be better to say it the other way, okay? And notice that it's not equal to either of those. It's greater than, okay? Because it couldn't be equal to it. Yes? I don't know if that would be wrong. It's probably not as right as what that would be. Typically, when you write it listed like that, you go from smallest to largest. Yeah, so this would probably be better than if it had been switched. I don't know if it's really wrong, but this is more right. Does that make sense? As you know, anytime like you're going to get into sets and stuff, they always go from smallest to largest. So that's probably good habit. All right. I want to determine the possible values of x. Okay, and again, there could be a range of values. Now, this is a little bit different than the last one that we did, because notice the length of the sides of the triangle. They all have an x, right? So what I'm going to have to do is look at 3 different possibilities, and then looking at those possibilities, come up with a range of values. Okay. All right. So what we have to do is we have to add these 2 sides together so that it's greater than this third side, and then add these 2 sides together so that it's greater than this third side, and then these 2 sides together so it's greater than that third side. Then we have to look at those answers and come up with the values. Okay. So we'll start with x plus 5 plus 5x minus 7, and that is going to be greater than 2x plus 22. So this gives me 6x minus 2 is greater than 2x plus 22. Bring the 2x over for 4x. Add 2 to both sides. Makes that 24. Divide both sides by 4. And x has to be greater than 6. That's one stipulation. Okay? Now I'm going to look at a second scenario. X plus 5 plus 2x plus 22 has to be greater than 5x minus 7. So here I get 3x plus 27 is greater than 5x minus 7. So I'm going to move 3x over here and add 7 to both sides, and then divide both sides by 2. And how would I read that? X is less than 17. Good. That's my second stipulation. Now I need to add these last 2 sides together. 5x minus 7 plus 2x plus 22, and it has to be greater than x plus 5. And so then you get 7x plus 15 is greater than x plus 5. Subtract x from both sides. Subtract 15 from both sides. Divide both sides by 6, and x is greater than a negative 5 thirds. about 1 2/3. Okay? 1.6 repeat. All right. Now, here are all of the stipulations. Okay? So that x has to be greater than 6, x has to be less than 17. It also says that x has to be greater than negative 1 2/3. You have to kind of go and plug it in. Make sure that it doesn't give you like a negative distance or a distance that's 0. Okay? Also, sometimes you can combine two and take the one that represents both. Okay, I'll talk about that in just a second. This doesn't look to be a problem, either one of these. But what about this one? It's negative. And why is that a problem? It can give you a negative distance. So that, like, if I put it in here, I would get a negative minus 7. That would give you a negative length, right? Okay? So, because of that, this guy would come out. Okay? That guy is out. So, my range of values would then be, x would be, what? Greater than 6 and less than 17. And that wouldn't necessarily matter. Okay. Now, just a different problem. Let's say my three scenarios were x is less than 15, x is greater than 2, and x is greater than 7. Okay, this is a totally different problem. It didn't work it out. But how would I determine what my values could be? What would be my upper limit? Yes.
It would be since scenario is greater than 2 and greater than 7, then you can just put greater than 7.
Right. That's what I'm looking for. Okay. So my lower limit would have to use this x is greater than 7, right? Because if I use this one, I would use a value like 3. But would 3 satisfy this stipulation? No, it would not, right? So if these are my three numbers, it would be x is greater than 7, and then my upper limit would be less than 15. Okay? So in this case, since I have 2 that it states it has to be greater, I have to one is going to take care of both. Okay? In this case, I was able to mix this one because it gave me a negative length. Does that make sense? Okay. Well, you're picking an upper limit and a lower limit. My upper limit's easy. It has to be less than 15. But my lower limit, I have two scenarios. One of them says that x has to be greater than 2. The other one says x has to be greater than 7. But I have to satisfy both of them. So I have to go with the x is greater than 7. Because if I chose the x is greater than 2, that would give me values that would work for x is greater than 7. Like, what are some numbers that are greater than 2? 4, right? 4 is greater than 2, but is 4 greater than 7? No. So that's why I couldn't use this one. I could only use that one. Does that make sense? Alright. The perpendicular segment from a point to a line is the shortest segment from a point to a line. Okay, this is here. We kind of talked about this a little bit. When you draw a line from a point to a line, there's all different ones that can be drawn, right? And we said that the true distance is always what? The thing to the thing. The what to the what? What does it have to do when you draw it to be the true distance? It is the. It's like the altitude. Altitude is what to the line? It makes perpendicular, right? It makes right angles. Okay. So the true distance is always the perpendicular distance, right? That is also always going to be the shortest. And that's what this here is. So it's the true distance from the point to the line. It's also the shortest distance from the point to the line. Okay? And the same thing would be true, this corollary here, from a point to a plane. So if I had, a plane up here and I was going to draw the shortest distance, it would be the perpendicular distance. So that again is the shortest. Alright, any questions?